How's it going, guys? I hope all are doing, and welcome to a brand new video tutorial from iPinwis. So in today's one, we're gonna discuss SQL versus NoSQL. So there's actually two type of database management systems that a lot of people falls apart. Like, what is the difference between that? Which one should I use in my projects? And why they have two types in that. So we're gonna discuss it in this video tutorial, and hopefully can give you a quick practical examples that actually can guide you through that and give you a quick idea of how SQL is actually organized and how NoSQL is organized, and what is the major differences between them and when you should use one over the other. And obviously we can just go ahead and start by looking down into a couple of pros and cons and what's the features of each type, and which one actually can be used over the other. So starting off with SQL databases. It's actually a relational, so tables and columns. And to give you quick idea about SQL databases, you can just go ahead and imagine MySQL in your head. If you've never used MySQL or something like that, I can give you just a quick overview of how that works. It's actually, by a relational database management system, we basically mean that there's tables like inside of a database. You can just imagine a database like a box, a big box inside of your head, and inside of this big box there's a couple of tables or other boxes, small boxes, and each box actually in this case represents a single SQL table. And why it's actually named SQL? Because it's has a SQL query. It's a programming language, just SQL thing that allows you to get the data, fetch it, and save it, and talk with the database management system. And inside of each one of these tables, there's actually columns, and each one is actually organized. Like you have, for example, a table for a user where the user actually have an ID, a unique ID, and username, a first name, last name, and probably, for example, an age or something like that describes the user in that particular case. And inside of this table, we can have like multiple records saved in this particular table. For example, we're gonna have 1,000 users, so they're all gonna have a relation to that particular table that have been created onto. And every single one has all the columns that we have assigned in this particular table. So this is basically what relational is. We've got complex queries and data fetching. So when you take a look, or you want to create an application like having a complicated data being fetched and doing a lot of sorting, or pretty much like getting a lot of important things or important data that you want to fetch from the actual database. So if you have that much of complexity in your application and you have to deal with that of a lot of manipulation, you definitely need to go for SQL, because it's much performance friendly and it gives you a rich tool set and a rich programming language and interface to interact with all different things and fetch the data you exactly want. Data availability and consistency. So when it comes to that, it actually pretty simple for the SQL databases, because it's very consistent and data always available in there. What I mean by that is actually when you're dealing with a SQL server, because you're gonna have like a SQL server and a SQL clients. Both of them are applications, part of the SQL, but they have completely different working or workflow in order to work into the actual database management system. So when talking to the SQL, what it does is actually going to reside in one single server. So that's actually what happens. It resides, or you're going to just put it in one single server. That's all you need, and all the data are going to be fetched in that particular server. While also there's other architecture about servers and putting in data servers and using load balancers and stuff like this, using multiple servers as nodes and distributing all the data inside of the servers. So yeah, it's much better to use SQL when you do that, like when you use one single server instead of multiple servers. But it actually depends on the scenario you're working on and other things, other factors. Mostly use it for one server data storage, and as I was talking right now, so you can just go ahead and use one single server. And there we go. But if you're thinking of multiple servers and you want to create, like, for example, a botnet or a server net, well, definitely SQL is not your choice. So this is basically it for a SQL database. We're going to see an example just in a second, to visualize that in your head. So NoSQL databases, for NoSQL databases, it's actually object-based. key value pairs. So if you're familiar with JavaScript, like a programming language that has a lot of objects and stuff like this is going to be very simple for you. It has like a key and a value identified particularly with that key, and then with that key only. So you can't access this thing only with its key. So you have first to know the key name, or the actual key, in order to be able to access the value. Otherwise you won't be able to. It's actually completely vice versa, or completely independent from a table or any relational things like that, and it has no relation to do with any of that. It's actually like objects based, and you need to access the value, you need the key. But on the other hand, when SQLs, what happens is actually you need the table name, then inside of the table name you need the column name, and you can fetch all the data inside of a column. So it's kind of a little bit confusing at first, but when you see the examples, you're gonna easily see behind the scenes of that. Designed for large amount of data, SN, it's basically when you're talking with like social networks is what an SN stands for, like Facebook or Twitter or something. They have a huge amount of data stored in there. So SQL, or pretty much NoSQL, is your choice to go for, and that's why they choose it, because you're gonna have multiple servers linked together in order to handle this much of large and huge data being saved and fetched like in a huge amount of places, and with a lot of requests and responses from the database. And it definitely need like a NoSQL architecture without dealing with the SQLs, because large amount of data is particularly made for NoSQL and designed for that particular job. It is very performance friendly when it comes to NoSQL versus SQL. SQL is a little bit performance heavily. It does a lot of, or it takes a lot of resources from the server you're running on, or from your computer if you're running this on a local machine. But when it comes to NoSQL, it's super performance, it's super lightweight, and it doesn't take that much of space or any RAM usage, because it doesn't do that much of calculation, much of queries and stuff like this as a SQL is. So that's why SQL is basically made for complicated queries, and when dealing with the complicated data and relations between tables. And it's very easy when it comes to scalable on multiple servers, and what is actually called on a NoSQL word, like for example MongoDB clusters. And yeah, each cluster has its own databases and they can talk to each other. So if you're thinking about that, putting your servers or putting your data in multiple clusters and splitting them among multiple servers, of course, it's just like go for NoSQL. That's basically it. Or if you're thinking and trying to create something similar to a social network where each user has its own information, he can post things, he can interact with things like do a like for example Facebook, or a retweet on Twitter or something like that. So each one has its own things. So you've got to go ahead and need to use an object-based database like NoSQL rather than going with relations, because nothing in that has any relations at all. So we can just jump back now into some practical examples into like getting that a little bit closer to you guys and to see what is actually going on behind the scenes. So we're starting off with SQL. So you can take a look on this particular table in here. It's pretty straightforward. It doesn't have that much of complicated. And this table, what does it represent is actually a normal user, or what I would like to call is actually a student. So let's say this is actually a student. We have a SQL table in here, and let's imagine we are working with MySQL database management system, and this is actually a table inside of that MySQL stored in there. So we've got ID on the left side in here. So the top row in here represents each column name. So we've got the ID, first name, last name, username, and its courses, all the student courses that he is actually currently studying. And on the ID pretty much going to be uniquely identifying each single user that has been, or each single student has been saved into the database with a unique ID. So the ID, this is actually the main idea between SQL databases when you have relations and stuff like that. So the ID is the main ID in this case. Each one of these has to get its own unique ID. It's really important, and you've got other data that you can actually put. But in this case, when it comes to SQL, we need relations. If you take a look on the right side of exactly or precisely going into the courses column, you're gonna find the cursor column actually has two values, and it's completely forbidden when it comes to MySQL database and relational databases. So each column has to have one single value. And also what we could have in here, so each table has a relation, has a direct or a functional relation to its own children. When it comes to that, what I mean by this, so a student has a first name, last name, and username, but not exactly or not precisely a student has courses. So you can just go ahead, jump into these courses and split it up into a table on itself. So it's really a bad idea to put the courses inside of the same table as the student table, because that makes no sense at all. Then we can go to the left side, we create the student table, which is going to be the same as the first table, with the first name, last name, username, and the uniquely identified ID for every single student. But lastly, we're going to go ahead and get rid of that completely of the courses column, because now it's completely forbidden and it's completely wrong to put the courses inside of the student table. We can't do that, and since we can't have multiple values into a very single cell. So this is what a relational database is about, and I'm gonna just talk to you about that in a second. But now we can go ahead into the right side and we can just jump into creating a brand new table for the course itself with its own uniquely identified ID. It have a name like web development, UI, UX design. You can put whatever names in here, like your courses are. Like for example, you can add React.js, Photoshop, Illustrator, so forth, so on and so forth. And the last column in here, what does it represent, is basically the user ID. And what I mean by this is actually here we are putting relations between both of these tables. Like we're gonna put the user ID, and here we can put which user has or is actually being taking this course, and by putting its own ID like 1. And when we took a look on the left side, we're gonna find Alex have the ID 1. So when you take a look on that, web development course is being taken by the Alex Brooks with the username Alex09B and so on and so forth. On the other hand, we also put the course ID inside of the student table, so we'll be able to easily from the student table to access the course, every single one. But instead of putting it all the data inside of that, like putting the courses and we put the data inside of that, we just go ahead and completely move it into a single standalone table, and we link that, or what we call them, relations. So we do like a quick link between both of these, and what I mean by links is just putting every single one, like the ID of the course inside of the table of the student, and the ID of the student inside of the course table, representing every single one of these, so they can actually match very easy, and we can just jump back and forth between those from every or each table we want to, and now they are actually linked. And this is what's called a relation between tables. That's why SQL is called a relational database. And this relation is actually many to many relation. Like students can have multiple courses, as well as courses can have multiple students being studying this particular course in the same time. So yeah, it's basically how relational databases work. You can't use the first version in there, it's completely wrong. And this is how relations are being made in a SQL database. And that's why if you're actually thinking about creating an application that uses that website or web application that pretty much needs this kind of relation, like a student related to a course and vice versa, a student has like for example its own account, has like a wallet or something like that. So each one of these has gonna be related into this. So you definitely need to use a SQL, because if you don't, or you jump back or jump straight into using, for example, NoSQL without any reason why you need to use SQL, well, it's just gonna do to you a lot of problems. Now we can just jump into NoSQL and see how is it being made. So for NoSQL, we can have the same structure as we did on a SQL, the same example with the students and the course. But in this case, as I've told you before, NoSQL is actually being composed of an object. And when I say that, you can just go and imagine an object, put it in your head like a normal JavaScript object that has a couple of properties that are being accessed from that. So it's pretty basic, like an object has its own properties or a key value pairs, and you only be able to access this particular value only by knowing the key. Otherwise, you won't be able to. So in this case, we're taking or examining an example of an object that is being made on MongoDB and NoSQL database. So we've got the ID, which is automatically assigned to you by the database management system, which is MongoDB. In this case, we are just using it. And the object's ID, it has an auto-generated ID for your objects to uniquely identify this objects and being able to access it as we did with the SQL databases. And we've got a couple of other things like normal columns. You can take those as columns, but in this case, they are not called columns, but indeed, they are actually called properties or a key value pairs. Each key has its own value. It can also have a null, but the most important part in here is you can clearly look. You can take a course, and a course actually can have the data that is inside of the courses, but we put it inside the student objects. So that's pretty great actually when it comes to that. When we took a look on the SQL, we said that we can't do that. We have to put a relation, like we have to take a course ID, we put it inside of the student's table. Then on the other hand, we also put the student ID inside of the course table, and that's what makes a relation between tables. So in this case, it's completely different. For the NoSQL, you've got to go ahead and take the data and put it all inside of an object. You can put arrays inside of objects. You can put objects inside of objects, which is called nested objects. And, many structured objects inside of each other's without any problems. And you have to put no relations because it comes to NoSQL, and this is how NoSQL actually works. And you can keep all of this data without any problems, with performance friendly, and you can have access to all of those. And obviously, for a NoSQL database management system, it has its own unique fields of working. So it can't work on everything. Sometimes you've got to go ahead and use SQL for actually a couple of particular ideas, application ideas, and systems that are designed specifically to be used through a SQL system. On the other hand, you can just go ahead and use NoSQL on other fields and other cases that supports NoSQL, like social network, Facebook, Twitter, whatever, all the social network has this particular structure. As you can clearly see, this is pretty unique. You can have like an array, a name of the course, and so on and so forth. And each student has its own schema. So all the objects inside of the student collection have to have the same structure or the same schema, to be saying. Like, what I mean by this, all of them has to get the same properties, the same number of properties. You can put null, of course, inside of it, like put username null, so it doesn't have a username. You can put required, which one of these, and so on and so forth. But in this case, you can't get or query like complicated data and have all these complicated things, like complicated structures, as a SQL can do. But you've got all of your data inside of an object without having any relations or something like that. You can easily go ahead and access it. So no relations between objects whatsoever. We can just jump and take quick 3 examples of a SQL databases. You might want to consider using it on your next project, or just think about it, or take a look on it, or search Google on it, or something like that. That's the first one and the most famous one, the MySQL, which is the great database management system that is widely famous. A lot of developers, a lot of companies use this database management system, and it has a lot of tutorials. So if you're, putting your hands on this and trying to learn this, like, just Google that out. You're gonna find plenty of them. You can go to Udemy, YouTube, whatsoever. There's the other one, which is Oracle Enterprise Database, and from its name, you just go ahead and imagine that's only made for enterprises, because it's supports performance and supports complicated data fetching and complicated SQL structure, queries, and so on and so forth. So it's only made for enterprises because it's just like a replacement for MySQL to big enterprises. So yeah, you've got to go ahead and use this for enterprises. And lastly but not least, there's the PostgreSQL SQL database that you can also use, which has or supports the SQL schema databases. So 3 of those. There's plenty of them. There's a lot of all of them. Just what I like and what I found most people actually love. So if you have anything different, you can just go ahead and put it in the comments below. And finally, there's the NoSQL databases. So it just picks up 3 that I actually love and I use, and I find a lot of other developers out there love and use as well. So there's MongoDB, was pretty much famous in this particular field of NoSQL database or NoSQL structure. When it comes to that, it's high performance, it's open source, and it gives you a lot of set of functionalities. I use it in my daily drives and in a regular basis, and it's pretty awesome thing. So you can go ahead and advise you to take a look on that with plenty of other tutorials that has been created. You can just take a look on my channel or other channels, whatever you like actually. So a lot of people are putting tutorials for that. There's also Redis, which is also made for enterprises and high performance. And lastly, there is the CouchDB, and it's pretty instantaneous and so awesome. 3 of those are NoSQL structures. Each one differs from the other with its own tool set, ecosystem, and third-party libraries and hooks, and plugins that you can empower the whole database management system. But just pick up one. I can go ahead and take a look on of that, and you can definitely have a better idea of how a NoSQL works, or how a SQL works, and what is the main difference. Because without taking it in action and just taking it in practice, you won't be able to take or make a decision between both of these and know the real difference just from a single video. So we really advise you to go with that. If you did understand what I did or the difference that I explained it to you throughout the video, I'll be very appreciated to put that like button, and you can go ahead and subscribe, put a comments and stuff like that. So thank you guys for watching. I really hope you guys enjoyed. I'll see you all in the next one.